Alaska, a state of spectacular landscapes, pristine beauty, abundant wildlife, magnificent waters, and dramatic extremes. Wind, rain, snow, ice, fire, floods, pounding surf, earthquakes, tsunamis, volcanoes, glaciers. And for all of us who live here, shelter is literally a matter of life and death. The exterior environment dramatically affects building structures, while the interior environment affects people, our health and safety, especially since so much time is spent indoors. These challenges energize and inspire northern builders. Jack Hebert of Fairbanks is a home builder and designer.
For 12,000 years, or perhaps more, depending on the anthropologist you talk to, people have been meeting that demand with creativity and innovation. This is an amazing place. We've got the worst weather outside of Mars or Antarctica you'd find. And we're proud of it.
Yes, we are.
And then we're dealing right now with weather and climate anomalies. Whether it's a natural cycle or whether it's a global warming caused by other things, we're having to address permafrost, erosion, our environment changing.
Such a setting led to the formation of the Cold Climate Housing Research Center. Award-winning architect and home builder Clay Porter of Anchorage is chairman of the Research Center Board.
The Cold Climate Housing Research Center, which is located in Fairbanks, Alaska, offers a real unique environment. The Cold Climate Housing Research Center evolved from a number of persistent questions and concerns professional builders had regarding design and function of building systems in Alaska. The builders saw a need for credible scientific research to improve home building technology and standards in Alaska. Now, the 1,000 plus members of the Alaska State Home Building Association are also members of the Research Center. Their involvement uniquely positions the center to link research objectives with practical experiences and the need for cold climate building.
Creating affordable housing has been another focus of builders.
We want to lower the cost to maintain buildings and also to build buildings. Affordable housing is becoming a tremendous issue, and healthy affordable housing is even a bigger issue. You can build something to get yourself out of the weather, but it can poison you as well. We want to be able to provide affordable, adequate, healthy, and durable housing.
Alaska provides a natural laboratory for such endeavors. The Cold Climate Housing Research Center conducts work in all regions of Alaska, from the polar North Slope to the temperate rainforests of the southeast. Headquarters are in Fairbanks, part of Alaska's interior region, and home to International Arctic Research Institutes of the University of Alaska.
The Cold Climate Housing Research Center, which is located in Fairbanks, Alaska, offers a real unique environment. It offers a 15,000 plus or minus heating degree day environment. It offers an indoor and an outdoor environment for cold weather testing.
Fairbanks historically has been a cold weather test site for both military and industrial products such as aircraft, including the Venerable Concorde, automobiles, and clothing. Home construction research would seem a natural.
We want to have a UL-approved lab. We want to have a Alaska-tested Alaska Tough. We want products to come here with an impeccable reputation for us to test them in a lab situation and outside. Our management team is an Alaskan team, but also an international team of people that have a common vision of improving housing and buildings for people in the circumpolar regions.
The Research Center has been involved in a variety of projects, both exciting and practical.
Tragic fire-related deaths in rural Alaskan homes created a call for an emergency egress window.
In a 3-week period, we developed a window that could withstand the racking pressures of a house on unstable foundations, that did not ice up, that had strong enough hardware that in a panic situation it would always open.
A mobile test lab is another ongoing project. The unit can test 9 different wall panels to see how wind and moisture affect performance. A number of studies address internal environment and system design, carbon monoxide, mold, and mildew. Dr. Mary Ellen Gordian of the University of Alaska's Institute of Circumpolar Health Studies is engaged in research funded by HUD.
By having very tight homes and not being able to open our windows very much during the winter, we have more pollutants within the homes. The work that I've been doing with the Cold Climate Housing Research Center has been looking at the effects of the indoor environment on children with asthma to see if there was any improvement in their asthma by improving the indoor environment. And that included both the air quality and also things like protecting them against dust mites.
The research center has expanded wall system envelope technologies.
In my own work and projects here in Anchorage, as both an architect and a builder, I have taken the remote envelope system and I'm going to use that on some townhouses in downtown Anchorage this year. And it provides a lot of flexibility and some very economic designs, as well as some very energy efficient methods for construction of these units.
Furnace design studies have provided practical research opportunities. Researcher Dr. John Davies.
Well, the problem that we were looking at was that people were using just rules of thumb to determine how big a furnace, taking the number of square feet in a house and certain number of BTUs per square foot, and saying that was good enough for, to determine how big a furnace. And people wanted, up here in the north, it's especially important to look at these issues because, it requires more energy to keep a house warm, and you want to make sure that the energy you're using efficiently. The problem was, though, that we started using way more energy than we thought we should be using. And we started looking into that as, why is it that with these bigger furnaces, instead of using a certain amount of energy, we're using like 30% more energy, and we've developed a program called Aquarm that calculated how much energy was supposed to be used by a house, and we would then compare how much energy was actually being used, and these houses were using more energy than they should have been.
The Research Center has now updated the software program, which is available through its website. Because of an urgent need for both in-house and field lab space, the Cold Climate Housing Research Center is planning to build a facility adjacent to and in partnership with the University of Alaska at its Fairbanks campus.
This will be an experimental facility from below the ground up. The structure itself sits on discontinuous permafrost, the site, in an area where less than half a degree temperature rise will create a situation where the permafrost will be disappearing.
The state-of-the-art facility will be a living test center.
So at 50 below zero at this site, and this is a bitter cold spot where this building is going, you'll be able to see how that building is actually performing.
The new test facility offers partnering opportunities for manufacturers who have materials that might be incorporated in the structure itself. The facility will permit testing of products under the strictest controlled laboratory conditions and out in the diverse environments of Alaska's vast territory, far greater than most U.S. maps depict. While the Research Center provides testing for circumpolar environments, results can be approximately matched to many lower 48 climate scenarios.
We invite you to put your home building products, systems, and ideas to the test at Alaska's Cold Weather Research Center.
We don't have a lot of air pollution coming from other sources. There aren't smokestacks. There is no industry. It's a pristine environment, except for what we bring to it.
Our mission is promoting the development and advancement of healthy, durable, and economically sound shelter for Alaskans and circumpolar people.